All right. How's it going?
Pretty good. How you doing?
Doing good. We got it.
Yeah. Good stuff.
All right. Cool.
Let me pull stuff up. You had a busy day?
Yeah, it's been pretty busy.
Yeah.
Yeah. Go next. So I work part-time too with school. And so it can be long.
Yeah. Where do you work at?
It's a company called Melaleuca.
Okay.
I work at their call center, so I just take people's orders and stuff. So
Nice. Get to deal with oil people. That's fun.
yeah. Right.
My mom's one of them, so I think I can make fun of them.
Yeah. What does she use? doTERRA?
Yeah.
Yeah.
She's one of those.
My mom is too.
Yep. I think they work sometimes, but
Yeah.
I also like doctors, so
Yeah, me too. I think there's a place for both.
yeah, definitely.
So,
Well, cool. Did you get a chance to look things over?
yeah, so um, I didn't have time to do the homework just yet, but I did all the reading and watched the videos. Um,
Awesome.
like I did do like the practice homework thing, but
Sorry. Yeah, it doesn't seem too bad. I didn't get to watch the video. How was that one?
it was pretty good. I actually feel like I do better with the videos than I do with the reading it. Reading it's kind of
Yeah,
confusing for me.
gotcha.
Uh,
I'll start watching those ones.
yeah, they're pretty good. The guy
Yeah,
explains it well.
cool.
So, all right. So I guess you want to just like jump on the quiz or
Yeah, I'm good to do that.
okay.
If that's all right with you.
Yeah, I'm good with that.
Sweet.
All right. So I guess number 3 says, "Are you on the quiz?"
I am. Yep, I'm good to go.
All right. So use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Okay. So we got to get the little apple t thing.
Say for this one, I got 0.175.
All right. You just add those two together.
So,
Oh.
you just type it in down at the bottom of that applet
Oh yeah.
because they're the z scores.
Mm-hmm.
1.358.
And then it gives you the area, huh?
Yeah, then you hit enter, and then if I remember, you just click because we want the left and the right, correct?
Mm-hmm.
So we just click on the left and the right, and it gives us that area underneath it.
All right. You said it's 0.175 after rounding.
Yep.
All right. Cool.
Does that match up to yours?
Yep.
Awesome.
All right.
Number 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? So I think this one kind of, remember, if it's above 30, that's when it can be a kind of a standard distribution.
Yeah.
Um, So this one, I'm not sure if it's the distribution of the sample means or that we cannot determine from the information.
Yeah. If the individual observations, that would be a lot bigger standard deviation, huh?
Yeah.
So
and the only part that in the chapter, it was near the bottom. It talked about when you can't find it.
talked about it near at the bottom.
Yeah, and the review of key concepts. Let me see.
Okay.
So, that number 1.
Okay.
To compute probabilities involving the sample mean, we must first determine if the sample mean is normally distributed. If it is not, we cannot compute probabilities. So, and it says the only way, there are 2 cases when sample mean is guaranteed to be normally distributed. They are the parent population is normally distributed, and the central limit theorem guarantees the distribution of the mean is normal if the sample size is large enough. For this course, we require the number to be greater than 30.
Okay.
So that's why I think it's this cannot be determined.
Yeah. That makes sense to me.
But I'm also distribution of the sample means. I don't know.
Yeah.
What's your thoughts?
Um, yeah, so I wouldn't say, 9's definitely not a large enough sample to pull from. So I feel like we don't have enough information for it.
Yeah.
So I feel good about
Now,
that.
cool. If it said it was normally distributed, I think we could go with that. But since we don't know,
Yeah, I agree with you.
cool.
All right. So number 5. Which of the following results implies that the spread in X decreases as the sample size increases?
I was thinking that was the central limit theorem.
Yeah.
Yeah, right there in that review of key concepts.
The second little blue bullet
Yep.
point.
Yeah, that one.
Yeah. Okay.
I like that one.
Yeah, that makes sense. That X thing stands for mean, right?
Yes.
Okay. Yeah. So you said central limit theorem?
Yep. I like that one.
Yeah, me too.
Okay. Go on to the next one. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and standard deviation of 8.8. So this girl earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diana's score?
All right. This one we have to use the formula.
Yeah. Was this formula, is it z-score equals, what is, I
Like
thought that was,
sample mean. Oh wait.
okay, yeah, sample mean minus mean. Anyway, Yeah, the sample mean. Or is it just a value?
I don't know. So I'm trying to. It's kind of funny. It's not like these are hard formulas. It's just that they're different from anything I've ever done before.
Yeah, it's with people throwing in letters.
Yeah, weird letters too.
Yeah.
So we're trying to find the z-score.
Yes.
Okay.
Okay. Do you remember? Is there a difference? That makes no sense. Difference between sample mean and mean?
The difference between what?
Sample mean and just regular mean or average?
If so, if I have it right in my head, the mean, just the normal mean is like the mean of all of the information, and the sample
Uh-huh.
is the average of just like a specific sample taken from the big group. I think,
Oh, okay.
but I'm definitely no expert.
I guess that would make sense. So, okay. So for this problem, our sample mean would be 160, correct?
I believe so. Hold on a sec. I got to plug in my computer. It's about
Oh, no problem.
okay. So let's see. What are we looking for again?
The z-score.
The z-score. Okay. Okay. And then the question you asked before I plugged in the computer was, what is the mean?
Yeah, or the sample mean.
Sample mean.
I think it's the 160.
Yeah. Or is that the value? Because that's Diane's score.
Yeah. Oh, yeah, that would be the X, right? The X with the line over it.
Um, well, we can try it. Let's go for it. I'm not sure.
Oh, okay. Oh, where would you put it?
Let's see. Equals 40. Oh. Also, the sample is the one that you take the square root of, I think.
Oh, is that okay?
All right. So, okay, so I know what's on the bottom. The bottom of it. So z equals, so the bottom is standard deviation divided by the square root of the random sample. So that would be, the standard deviation is 8.8 divided by the square root of 160.
Uh-huh.
Okay. And then on top, um, I did, okay. 20, okay, hold on a sec. Oh, it's, I think it's,
So would we put the square root of 1 because there's only one value?
maybe, I don't know if I'm looking at the right formula anymore. Okay. Yeah, I don't think I have. What's the z-score formula?
So on the reading, it's under number 3.
So z equals value minus mean divided by standard deviation.
Yes.
Okay, so I was looking at the wrong thing then.
Okay.
Sorry about
So
that. So z equals
would it be 160
minus.
minus? Was it 150.8?
So I think the value is 160, and the mean is
Yep.
150.8, and then divide it all by the standard deviation.
I think so because it's only one unit, right? Or one number.
Yeah.
Except that gave me a really big number.
Oh, really?
Yeah, I just got 142.86.
Okay, let me see what I get. So I got 1.04. So
You
I
want to
did,
walk
I
me
guess,
through
so the way
what you
I set
did?
it up, I did 160 minus 150.8 divided
Uh-huh.
by 8.8. Did I miss a square root or something?
That's what I did too. Oh. Okay, I just did it again. Oh, I think I didn't have the problem set up right. Yeah, so I got 1.045. Is that
Yeah, that's what I got.
okay? So, okay, yeah, I think I'm good with that answer.
Yeah, me too.
Cool.
So
Okay. So
and
now for the next one, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So we can plug in the z-score we just found, right?
is the z-score the same as the probability?
So, could we use the z-score to find the area, which I think area is same as probability.
You're talking like an apple T.
Yeah,
Apple.
the applet, yeah. So if you put in the z-score there, 1.045,
Mm-hmm.
the area of the applet to the right of that z-score,
Mm-hmm.
of the positive z-score, you get 0.1480.
Yeah, that's what I get.
So I think that's the probability. So if you make that a percent, it'd be like 14.8%.
Okay.
We'll get above that.
It wants to leave it as a decimal though, right?
Yeah. So 0.148. That's what I think.
Yeah. I feel good about that.
So
It is above 160, so
yep.
okay. So number 8. Random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' scores? So we just need to calculate everything.
So I got 160 as the average. Is that? Well, I guess maybe that's not necessary.
We do need to find the mean. So
do we use the mean from above?
I don't think so. Oh, it does say the next 4 questions. So 6, 7, 8. Okay.
So.
Oh, that's the sample mean of these students' scores. So the mean is 160.
Okay.
How do we find the? Is it so? The standard deviation would probably still be the same, right?
Yeah.
So if the mean is 160 and the standard deviation is 8.8,
Yep.
what's the value for this one?
For this one, I put that 160 as the sample mean.
Okay.
Or as the X.
Oh, as the x?
Yeah, and then I use the 150.8 as the mean.
Okay, so you had 160 minus 150.8 again?
Yep. And then divide that by the 8.8 standard deviation divided by the square root of 5. That's how I think it's set up.
Okay. And then I guess what did you get?
I got 2.337, 338.
2.338.
Which, but I don't know why that number makes sense, or if it does make sense.
Yeah. Let's see here. I'm trying to figure that out too. Okay. Are we sure we use the mean from the question above it?
I think so, because I wouldn't know what else to put into X.
Yeah, that's true. It doesn't really give anything else to you.
No, and I think because that X is called the sample mean, I'm thinking it'd
Yeah.
be that average.
Okay. Go on. I feel comfortable going with it.
I'm kind of on the fence with it.
Yeah.
I don't know what else to put in there, but that's about as
Yeah.
good as it's gonna get.
I don't know what else to do with it. So
Yeah. But I guess it does make sense that because you're trying to figure out the average of what are the chances of these people having, you know, 160,
hmm
5 students in a row, like randomly picked. So chances are that that won't happen, which would make sense why our Z score is so big.
yeah, that does make sense.
I think we can justify it that way.
Yeah. I think you're right.
Okay.
Then on to number 9.
Yep.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? You put that one in the applet.
Oh, yeah, that's exactly it. So 0.00
9, 7.
or point does that round up to 0.01?
Oh yeah.
Which one are you going with?
Says to round your answer to 4 decimal places.
Oh, does it?
Yeah, that's what it says. So 0097.
97. Good eye. Cool. 0.0097.
Yep.
Awesome. Number 10. Suppose that the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected?
Be approximately normal, wouldn't it? Because it's above 30.
I believe so.
Okay.
I'm good with approximately normal.
Yeah, me too. Then what is the mean of the distribution of the sampling distribution for all possible samples of size 81 that could be drawn from the parent population? Okay. What is the mean of the distribution of the sample means for all possible samples of size 81?
Does that question make any sense?
Not really.
Okay, glad we're on the same page.
Okay. Mean of the distribution of sample means. Okay. I'm not sure. I remember reading anything about the mean of the distribution of sample means.
Yeah, I don't.
Okay.
I just did they give any values?
Not really. What is the mean of the distribution of the sample means? Oh, okay. So the mean GPA of BYU Idaho students is 3.5, and the standard deviation is 0.7. It's well known that distribution is left skewed. A random sample of n equals 81 students will be drawn. Okay. To find the mean of the distribution of sample means. So n equals 81. How do we find? Okay.
Oh, okay. I think I just came across it.
Okay.
So no, maybe not. Wait, would the mean be 3.5?
I'm not sure. I kind of wondered that. It kind of sounds like we're trying to find the mean of the 81 samples, the samples of the size 81.
Uh-huh. So because we know it's normal, I'm trying to figure out what they did in the example under example 3 in the reading.
Yeah.
They kind of pulled that number 10 out of somewhere. It's like they took the average and added the standard deviation.
Hmm. Yeah, it might just be 3.5.
But I don't.
I don't feel like, I guess the way, like, it's, I don't think that there's enough information to find the mean of the 81 samples.
Yeah, I don't. Especially when we're not given a number.
Yeah.
Huh.
So I'm guessing,
3.5.
yeah.
Uh, and it says round it to 1 decimal, so maybe that's it.
Yeah, maybe.
Yeah, I think I think 3.5 will work.
Yes, we'll say 3.5. What is the standard deviation of the distribution of the sample means? All possible samples of size 81 that can be drawn from the parent population.
.7.
I'm guessing so.
I feel these are too easy.
Yeah.
Oh, it says round your answer to 3 decimal places. I don't.
Yeah.
Oh, would you do 0.7 divided by 81? Because so you do, where's that?
0.0086.
What do you think about that one?
Is that somewhere on how to find the standard deviation?
Yeah, so the standard deviation formula is deviation over, it'd be square root, sorry, square root of 81.
Okay.
So 0.077 repeating.
So what'd you say it was?
I think it's, um, 0.0778. Well, 0.078.
0.078.
Yeah. So I took 0.7, the standard deviation, and divided by square root of 81 and got that.
Okay.
I think that's the formula.
All right. So 13 was the probability that the mean GPA for any one randomly selected BYU Idaho students will be less than 3.3. We use the applet for that. Or we need to find the z-score, huh?
Yeah, I think we'll have to do the z-score first.
Okay. So n equals 81. 81 minus our mean is 3.5.
I think would it be 3.3 minus 3.5?
Where'd you get the 3.3?
That's the randomly selected student will be less than 3.3.
Oh, yeah. You're right. 3.3 minus 3.5.
And then our 81, I think would go in the where n goes.
That's so it's square root of 81. So it'd be, what's our standard deviation again?
0.7.
Or do we use our new standard deviation, the 0.078?
Dang, good question. Well, I guess either way, because in our formula we do 0.7, we do standard deviation again.
Oh, okay.
Does that make sense?
Oh, yeah. Yeah, it does.
So I think so. We do end up using that new number.
Okay.
I just
Use
did an extra step.
So use the 0.7 first.
So you can use just that number for your bottom number.
Oh, the 0.00,
Yeah,
0.07. Okay. Oh, yeah, that makes more sense now.
because we already found that one out by doing what the formula says to do.
You're right. You get negative 2.56.
I got close. I got negative 2.57.
Okay. And plug that into the z-score. And it'll be less than 3.3.
To the left, right?
Yeah. Or were we just supposed to put 3.3 in the applet for the z-score?
I don't know if that would.
I don't know why that just came across my mind, but
I don't know. I think you have to convert it to the z-score.
okay. So you click all of it except for what's right of the 2.57, correct?
So we're going. It asks for less, right?
Yeah, it will be
So
less than 3.3.
oh wait, let me. Yeah, so I clicked everything to the left of just that one little section
Mm-hmm.
left of negative 2.5657,
Yeah.
and I got 0.0051.
All right. You wouldn't click the middle part, because that's below 3.32, isn't it?
So I don't think it is. Because where zero is at, I believe that's where 3.5 would be.
Okay.
So did you get 0.005 or did you get something different?
Oh, yeah, I did.
Cool.
Okay.
Now for 14, I think we just click everything but what we just clicked. So the other two sections.
Okay.
So I got 0.9949.
All right. Yeah, same. And that rounds up to 0.995.
Yep.
Okay. 15, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boat accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Okay. So the mean weight used to be 185.
So
standard deviation is 26.7. The weight of a random sample, 48. Sample mean was determined to be 177.6. So we need to find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean. Our sample mean is 177.6. And we need to find the probability that a random sample of passengers will be like way more or way less.
Okay.
We need to find the z-score of this one as well.
I believe so.
Okay. So we do the sample mean 177.6 minus the old mean 185.
Yep.
Okay. And then standard deviation, let's see. Would just be divided by 26.7, or do we have to do something with the 48, the sample of 48 as well?
So yeah, so I think we do 26.7 divided by the square root of 48.
Okay.
That's, and then just divide those together. So I got negative 1.92. For the z-score.
Okay. Almost there. What'd you get? Negative.
1.92.
All right, that's what I got.
Awesome.
That's the z-score. We need to find the probability of random sample passengers will have a weight that is as extreme or more extreme.
So if we put that as the z-score and then click the two sides, would that give us the probability of our extremes?
I think so. 0.0549.
Yep.
Awesome.
Cool.
It doesn't say to round it. 3 decimal places.
3 decimal place, yeah. So 0.055.
I believe so.
Cool. Who's submitting first?
I'll go ahead and go first.
Okay.
We'll see how bad the damage is.
Take one for the team.
All right, so we got number 4 wrong.
Okay.
And number 5. Wow, we got everything else right though.
Nice. That was 4 and 5.
Yeah, the ones I thought were the easy ones. 4 is which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? And we said this cannot be determined from the information given. So
Okay.
it's got to be the other one. And then
I'm
5
gonna
was,
say, yeah, distribution of sample means, right?
Hmm?
The
Oh.
distribution of the sample means?
Yeah.
Okay. And then 5.
We said central limit theorem. Which of the following results implies that the spread in X and the spread in whatever that number X with a line over means decreases as the sample size increases?
So it's not central limit theorem.
Nope.
Well, what other terms did we talk about?
Normal distribution, the 68, 95, 99.7 rule, or the law of large numbers. Would it be normal distribution?
Since that's what we talked about this whole time.
Yeah.
Probably. Sorry about that. Yeah.
Open up the other quiz. Because we
Nope.
It's kind of funny. I didn't feel very confident in a lot of those, but like we actually got them. I guess not a lot of them. There were some I was just kind of unsure about, you know?
Yeah, no, it's pretty cool stuff we can do with that simple equation.
Yeah, it is. Whoever figured that out.
Yeah. So do you want me to read the answers off to you?
Yeah, sure. What
Yeah.
do we think number 3? What's number 3?
Oh, did we get number 3 wrong?
No, number 3 is right. I can go back and forth, but
Okay, I say 0.1175.
0.175. Okay. Number 4, are we going to say it's the distribution of the sample means?
Yeah.
Okay. And number 5, normal distribution.
Yep.
Okay. Number 6, what was that one?
1.045.
1.045. Okay. Number 7.
0.148.
Okay. Number 8.
2.338.
Okay. Number 9.
0.0097.
2097. Okay. Number 10.
You had 2 zeros in that one, right?
0.0097. Yep.
Yep. Awesome.
What was number 10?
Approximately normal.
Okay. 11.
3.5.
Okay. 12.
0.078.
Okay. 13.
0.005.
0.005.
Yep.
Okay. 14.
0.995.
995. And 15.
0.055.
0.055.
Yep. Let me submit mine real quick. Make sure we got
Okay.
those first 2. Oh, okay. So number 5 we got wrong.
Oh,
Yeah.
really? Did we get number 4 right?
Yeah, number 4 we got right.
So number 5. Either the law of large numbers or the 68, 95, 99.7 rule.
Oh, shoot.
Is it the 68, 95, 99.7 rule? The spread in X decreases, sample size increases.
So the value or sample mean decreases as the sample size increases. Maybe that's the law of large numbers.
Yeah.
I'm thinking it's that one.
I'll just go for it. Hey, that's right.
Is it?
Yeah.
Nice.
So cool. Woo, we did it.
Good stuff.
Very good stuff. Cool.
Well, thank you for meeting.
Yeah, thank you. I'm glad we were able to figure that out.
Yep.
And
So it's the law of large numbers, right?
yeah.
Cool.
And I'll go ahead and I'll post this on the group collaboration thing too.
Awesome.
So we can get credit. So
Great. Thank you so much.
all right, thank you. Have a good night.
You as well. We'll see you.
All right,
Bye.
bye.